So here's our example problem. We have a mailbag being dropped from a helicopter. Now when it's dropped, the helicopter was already descending at a steady rate of 1.5 meters per second. So we're asked to find after 2 seconds what is the speed of the bag, and then also how far is the bag below the helicopter after the 2 seconds. So if we're going to solve this problem, the first thing we should do, as always, is to draw a picture. So here's my helicopter. And the helicopter has a mailbag, and before it drops the mailbag, it is descending at a steady rate of 1.5 meters per second. Then it lets go of the bag and allows it to fall. And the bag starts falling downwards and accelerates under the influence of gravity. So the next thing I should do is write down the knowns and unknowns for my problem. So for part A, at this point, the things that I know about the bag, so here I am looking specifically at the motion of the bag, and the things that I know is that the bag initially is moving downward along with the helicopter. So initially, the velocity of the bag is 1.5 meters per second. And since the bag is moving downwards, that's a negative velocity. So it's a velocity of 1.5 meters per second, but it's in the downward, or the negative y direction. I know also that the bag falls for 2 seconds, and I'm interested in the motion at the end of those 2 seconds. And then my unknown for part A is what's the speed of the bag? I want to know what is the final velocity. So now I can take a look at my freefall equations. And I want to select one that involves my knowns and my unknown. And another thing, of course, that I know is I know the value of g. So if I look at my expressions, it looks like this first one might do the trick. So that first expression says that v is equal to v naught minus gt. And I know the value of v naught, I know the value of g, and also of t. Now this equation is already arranged to solve for my unknown, so I can just go ahead and plug in the numbers. My v naught is negative 1.5 meters per second, minus g is always positive 9.8 meters per second squared, because I took care of the minus sign in my equation. And then I need to multiply that by the 2 seconds. So that will give me a final velocity then of negative 21.1 meters per second. And that makes sense that it's negative because I expect that after the 2 seconds the bag would still be falling downward. So a velocity in the downward direction is a negative velocity with the coordinates that I've chosen. So then part B asks how far is the bag below the helicopter? So now I need to have a new set of knowns and unknowns. So what are my new knowns and unknowns? So now I know quite a bit more. I know that, as before, the initial velocity is negative 1.5 meters per second, that the bag falls for 2 seconds, and I now know that the final velocity is negative 21.1 meters per second. My unknown, the thing that I'm trying to find in this part of the problem, is how far does the bag travel? What is its delta y? So now I can go back to my freefall equations and look for ones that will give me my delta y given the information that I know. So it looks at this point like there are multiple equations that I could use to solve for delta y. I've solved for one thing already, and I have a lot of information at this point. So I guess I'll choose maybe this second equation, which is that delta y is equal to 1/2 v naught plus v times time. Although I could have just as well have chosen this one or this one. Any of those three would work. So if I plug in numbers here, I have 1/2. My initial velocity is negative 1.5 meters per second, plus the final velocity is negative 21.1 meters per second. And then I need to multiply that by time, which is 2 seconds. So if I plug that into my calculator, I find a delta y of negative 22.6 meters. And that makes sense that I got a negative value because I expect the displacement of my bag to be negative because the bag is falling downwards. So if the bag had moved upwards, my delta y would be positive, but since the bag is moving downwards, the delta y should be negative. So at this point, am I done? Well, not quite, because I found out how far the bag fell, but this is how far the bag went during its fall from its release point. And while the bag was falling, that helicopter was still moving downward. So the helicopter also descended during this 2-second interval. So this is the delta y for the bag. I better also find the delta y for the helicopter. Now the helicopter was not accelerating. The helicopter is descending at a steady rate of 1.5 meters per second. So that means that if it's going at a steady rate, its velocity is not changing. It's moving at a constant velocity, so I can use the constant velocity expression. Now in this case, the helicopter was descending in the y direction, so instead of delta x, I'll use a delta y. Delta y is equal to velocity times time. Now the helicopter is moving downward steadily at 1.5 meters per second. So the velocity of the helicopter is negative 1.5 meters per second. And my time interval is 2 seconds. So during the same time interval, the helicopter moved downward a distance of 3 meters. So while the bag descended 22.6 meters, the helicopter descended 3 meters. So if I want to know then the distance between the bag and the helicopter at the end of the 2 seconds, I would need to take my 22.6 meters and subtract off of that my 3 meters. So at the end of the time interval, I would get a difference of 19.6 meters between the bag and the helicopter. So I would say that the bag is 19.6 meters below the helicopter. And that would be my response to part B. So here is a question for you. Let's say there is a student at the top of a building of height h, and they throw one ball upward with a speed of v naught, and then they throw a second ball downward with the same initial speed v0. How would the final velocities compare when the balls reach the ground?